When we use the term redundancy in probability, we're referring to the duplication of critical components or functions of a system with the intention of increasing the reliability of the system. So another word for that might be a backup. In these types of problems, we apply the multiplication rule for independent events. So let's look at redundancy through an example. Okay. The IT department runs 3 redundant computer servers concurrently. For each server, there is a 14% chance of crashing in a given day. Assume that a server crashing is independent from any other server crashing. So here we have our independent events. A server crashing would be, those are independent events for each of the 3. What is the probability that none of the 3 servers will crash on any given day? Okay, well, let's look at the information we've been given. We've been told that these are independent events. Each server's operation is an independent event. We've been told that the probability of a crash for each of the servers is 14% or 0.14. So therefore the probability of, well, let me write this over here, the probability of no crash would be equal to 1 minus the probability of a crash, which is equal to 1 minus 0.14 or 0.86. So that's true for each one of our servers. Okay, so back to part A. What is the probability that none of the 3 servers will crash on any given day? So let's write that out. Probability none crash. Okay, well, that will only happen if we have the probability that number 1, I'll just write no crash, and probability that number 2, no crash, and number 3, no crash. That's what has to happen. That's what we're asking. What's the probability none crash? So that 1 doesn't crash, 2 doesn't crash, and this word and, multiplication rule, 3 does not crash. Okay, well, this is the multiplication rule. So note that because of the word and, we know we're going to use the multiplication rule. We've been told they're independent events, so we do not have to worry about conditional probability. So this is the probability. Number 1, no crash. Oops, I didn't write my 1. Times the probability number 2, no crash, times the probability number 3, no crash. Okay, well, we know what the probability of no crash is. We said that was 0.86 for each one of these independent events. So 0.86, no crash for server number 2, 0.86. No crash for server number 3, 0.86. And let's get used to seeing this written more simply. We could say, since we have 3 servers with a probability of not crashing at 0.86, we could write that as 0.86 to the 3rd power. And that calculation yields 0.636056. So we could say approximately, I'll abbreviate that, approximately 63.6% chance that none of the servers crash. Okay, but let's think about this a minute. that doesn't mean that that's the probability that the system continues to operate, because recall that we only need one server to be running for the system to operate. So as long as at least one is running, we don't have a network outage. But so we probably would be interested in finding out what's the probability that that would happen. What's the probability of no network outage on a given day? So how would we figure that out? Well, no outage would happen if just server number 1 went down, because you'd still have 2 running, or if just server number 2 went down, because you'd have 1 and 3 still running, or if server number 3 went down, you'd still have 1 and 2, or the combinations of 2. 1 and 2 could go down. As long as 3 is still running, you still don't have an outage. If 1 and 3 go down, you still have 2 running, no outage. So there are so many ways. That's what the redundancy accomplishes, so many different ways to keep this network running, because we have so many combinations of crashes and still continue to have a running operating network. So that would be quite a complicated calculation. And this is one case where it's really, really helpful to know how to use the rule of complements. So the probability of no outage, with all those different combinations that make that possible, but that has to be equal to 1 minus the probability of an outage. Now, there's only one way for this to happen, right? The only way you'll have an outage is only one condition: all 3 servers go down. Much easier to calculate than all the combinations of having 1 server still running, or 2 servers still running, or all 3 servers still running. That would be many, many different things to consider. Here, we just have to look at, well, what's the probability of an outage, and then subtract that from 1, because you either have 1 or you don't. Okay, well, let's think of what would be the probability then of an outage. Let's find that. We said the only way that happens is if number 1 crashes and number 2 crashes and number 3 crashes. That's what has to happen for the whole network to shut down. So these are independent events. The word is and, so we use the multiplication rule. The probability number 1 crashes times the probability that number 2 crashes times the probability that number 3 crashes. Okay, so what was the probability that any one of these would crash? Here we wrote it up here. The probability of a crash, 0.14. Okay, so this equals 0.14 times 0.14 times 0.14, or much more simply, 0.14 to the 3rd power. And that calculation yields 0.002744. But this is not the number we're looking for, not the probability of an outage, but we want to know what's the probability that we don't have an outage on any given day. So that's our next step. The probability of no outage, we said, let's fix that. No outage is equal to 1 minus the probability of an outage, which we are saying here is 1 minus 0.002744, and the result of that is 0.99725 6. And what we can say here, let's slide this up a little bit, I'll abbreviate, approximately a 99.7% chance of no outage. So that's an important thing for the network manager to understand about his system. He knows that each server only has a 0.8% chance of not crashing, as we saw, 1 minus 0.14. That's not a great performance there, but if he backs it up with 2 other servers, he has a really good chance of the network staying operational and no outage. So this is an example of an important type of problem in probability called redundancy.